This next slide reviews the visual analog scale, which is a performance metric for activities of daily living and work. And what you see in this particular result table is that those in the humic acid group were performing better at the end of week 1, at the end of week 2 than those in the placebo group. But most notably, you see for those between the ages of 40 and 60, there was a substantially significant improvement in the visual analog scale for the humic acid group relative to those in the placebo group. Now, when we start looking at inflammatory markers and we focus on tumor necrosis factor alpha, TNF alpha on the left, you see that there's a significant suppression in the humic acid group of 26.7% versus 7.1% in the placebo group. And what's notable here is that TNF alpha levels were lower across the study in the humic acid group, carte blanche. But what this says to you is that humic acid has an anti-inflammatory push, which we initially illuminated. Let's do this one again. This particular slide reviews the anti-inflammatory effects of humic acid in terms of tumor necrosis factor alpha and interleukin 8. When you look at the table on the left for TNF alpha, you see a suppression of 26.7% in the humic acid group versus 7.1% in the placebo group. The take-home message here is that humic acid, in terms of tumor necrosis factor alpha, has an anti-inflammatory effect. TNF alpha, left unchecked, is a pro-inflammatory cytokine that drives an inflammatory response that we would follow in a variety of clinical situations. Now, on the right, you see interleukin 8. And interleukin 8 is interesting because you don't want a lot of interleukin 8 suppression. More suppression of interleukin 8 would suggest that there's some immune system suppression. And what you see in the middle column here for the humic acid group is a decrease in interleukin 8 of 3.2% versus 10.2% for the placebo group. So this may suggest that there's preservation of the immune response or less suppression of the immune response in the humic acid group versus placebo. When we look at immune system cells in terms of CD4 and CD8 in this next slide, what's notable here is the net change between the humic acid group and the placebo group, regardless of whether we're talking about CD4 or CD8 cells. The take-home message here is that humic acid may have some role in modulating the immune response, since we see augmentation or an increase in CD4 and CD8 cells in the humic acid group. So what did we see in terms of adverse effects of using humic acid in this particular study? The most common issues were gastrointestinal in terms of diarrhea, stomach aches, and discomfort, which we understand or would expect given what humic acid is. In the presence of water, humic acid, let's take a step back. In terms of adverse events, this particular slide details a higher incidence of gastrointestinal side effects with the use of humic acid in terms of diarrhea and stomach cramps versus the placebo group. Now, you'll note on the far left that there were some elevated liver enzymes identified during the study, in this case in 2 participants in the humic acid group and then 1 participant in the placebo group. The reason for that increase in LFTs or liver function studies is not understood. It was opined that it may have been related to drinking. So let's move from a conversation involving humic acid into peptides. Because what we're moving towards is combining humic acid with a custom designed peptide to address the COVID-19 infection. So what are peptides? So they are 2 or more amino acids that are linked together. They're typically between 2 and 50 amino acids in length. And anything more than 50 amino acids would be qualified as a protein. This schematic illustrates amino acids as the building blocks of protein on the far left. And then you see a peptide chain in the middle. And as that chain grows, in this case beyond 50 amino acids, you develop a protein. And you see that the protein is actually folded and twisted, which is typical of protein in real life. This next slide is a list of amino acids. And the take-home message relative to peptides and protein in general is that they drive life, they drive biology. So let's take a look at some of those. So insulin is a peptide. It's composed. So let's take a look at a very common peptide, namely insulin. Insulin is comprised of two peptides, one chain of 21 amino acids, another of 30 amino acids. Insulin is something that we pay attention to for those with diabetes and insulin resistance. And the two chains, that's not good in this instance. Let's focus on a very common peptide, namely insulin. Insulin is commonly understood to be a hormone, but in fact, it's a protein. Let's focus on insulin as an example of a peptide. You can see from the illustration on the right the three-dimensional matrix of the insulin protein, which is really a combination of a 21 amino acid chain in blue with a 30 amino acid chain in green. Another example of a peptide, which in this case is termed a hormone, is growth hormone. But this is a 191 amino acid sequence, and by virtue of that size, it qualifies as a protein, but in the nomenclature, we refer to it as a hormone based on its action. Other peptides that are commonly available in the market include glutathione, which is an antioxidant. Glutathione is a tripeptide, meaning it has 3 amino acids. Another therapeutic alternative that is available in the United States is BPC 157, which is a pentadecapeptide. That means it has 15 amino acids. Other peptide examples that we work with clinically include cerebrolysin and dihexa to stimulate the brain, thymosins to stimulate immune system activity. There are, of course, cosmeceutical products that are used to promote collagen production in the skin. And then there are bioregulators such as epithalin. This particular slide illuminates a proof of concept, and that's why it's included. All that I want you to get from here is in this particular study that was performed, the researchers applied peptides to COVID-19, and you see that there's an inhibition of cell-to-cell fusion, as well as an inhibition of infection in the presence of peptide. This particular molecular diagram illuminates humic acid in combination with the synthetic peptide to the far right of the screen. So let's look at humic acid plus peptide relative to what's been developed internally. The peptide sequence that has... Let's look at humic acid in the combination of peptide. Years ago, our research group the peptide that we designed years ago and attached to humic acid is a 14 amino acid chain that we now know, based on in vitro testing, binds to the S-glycoprotein of COVID-19. We don't know. We haven't published that. Okay. Moving on from the molecular model of humic acid with peptide, the peptide that was designed years ago relative to the humic acid peptide combination that is illustrated here, the peptide that's been included in product development is a 14 amino acid sequence that has been established in vitro to bind to S-glycoproteins. And by doing that, it anchors humic acid to the virus with a much higher affinity than humic acid binds on its own. The following is a result of some in vitro studies looking at the antiviral properties of humic acid in combination with the polypeptide designed by the group. And you can see on the far left that in the presence of herpes simplex, the humic acid plus peptide kills 100% of the virus within 3 days. For HSV2, it kills 60% of the virus in 3 days. In terms of inhibiting viral fusion, with cytomegalovirus, you achieve 100% inhibition by 3 days. In terms of RSV2, or respiratory syncytial virus, which can cause upper respiratory infections, you see 100% inhibition after 3 days. So let's look at the mechanism of action based on what's currently known. Humic acid encapsulates the virus and prevents binding to cell membrane receptors. The peptide binds to the spike proteins and locks humic acid to its target virus. And what's really interesting about this particular combination of humic acid with peptide is that by virtue of the size of humic acid, it's relatively indifferent to antigenic shift or adaptations of the virus to its environment. So what are we seeing in terms of real-world data when we take the humic acid peptide product and put it in the field? And in this case, we've deployed 285,100 doses of humic acid and peptide in China, Hong Kong, Singapore, and South Korea. And as a case example, I want to look at a family in Singapore between the ages of 20 and 54. In Singapore, when you have an assay for COVID-19 that is positive, you are transported by ambulance to the hospital. And discharge criteria from the hospital are that you have to have 2 COVID-19 assays that are negative 24 hours apart, back to back. For the family that was hospitalized, they were each given 2 tablets of humic acid plus peptide 3 times a day for 3 days. 24 hours after admission, their assays were negative. 24 hours following that, the assays remained negative, and they were discharged from hospital at day 3. What are typical dosing instructions? To prevent infection, 1 tablet of humic acid plus peptide once or twice a day. Let's change that. What are the dosing instructions? To prevent infection, we recommend 1 to 2 tablets of humic acid plus peptide daily. To treat an infection, we recommend 2 to 3 tablets or capsules 3 times a day. Thank you very much.